Hi everybody. I'm Carmen, and today I am going to speak about Polymer and Smileys that are my favorites. So in one word, I'm going to speak about Polysmileys. So just a few words about myself. Hi, first of all, again. This is me. This is Carmen on Twitter. You can find me under this Twitter handle. There are a few things you need to know about me. A first one is that I really love trampolines. So wherever I find them, I just go and I jump up and down on them. And the other thing you need to know is that I'm very happy when I'm around cakes. Like the more, the merrier. And they put this like huge smile on my face. And that's usually very cool. I also love ASCII smileys. I fell in love with them like a few years ago when I discovered them. And I was like, yay, they're so cool. So ever since then, I like spread them here and there when I'm writing emails or things like that. My favorite ASCII smiley is that one, is the little fellow over there. And I have a ++ version of it, which actually smiles back at you. I want to tell you a few things about this talk. So when I was preparing my slides, there was this person who asked me if I could give him a summary of the talk. Apparently, he didn't really get the whole thing about the poly smiley, so he wanted some clarifications on that. The idea came from the fact that, so I've been working with web components. I've been also talking about them here and there. And I've always wanted to try Polymer as well. So I was thinking, when I was submitting for this conference, I was thinking, what would be cool to do? And then I was, yeah, well, I would like to work with Polymer, and I really love smileys. And then all of a sudden, this idea of poly smileys came out. So it's not an official thing. It's just a name that I made up. But I'm actually very happy with it. And I really hope you'll also enjoy like all the work that I did for this presentation. Why? Because I really think that ASCIIs, especially ASCII smileys, make the web a better place. It's like they always make it nicer and more friendlier. Another thing that you need to know about this talk is that pink is not the coolest color ever, but sometimes it can really be fun. That would also kind of explain the pinkish backgrounds that you'll see here and there. And speaking of the backgrounds, what I also found out with this talk is that random pictures that you take from the airplane sometimes, they can really be useful when you're doing talks. So all the pictures that you're gonna see in this talk, they're just pictures from like that I randomly took, and then they turned out to just make this presentation nicer. I want to give a shout out to two guys. I don't personally know them, but this talk would have not happened without their work. So first of all these slides that you're going to see, they're basically a Polymer element. I'm using Super Presentation, which was made by Guilherme. And all the code snippets that you will see, that's also another Polymer element that was made by Felipe. And you can have the links in the slides. You can just check the codes out. They're really, really cool. So thank you to them. And the last warning that I want to give you is that this talk is, well, obviously going to contain an overdose of smileys, as in like many of them. So if you, I hope it will be okay for you. Like at the end of the talk, who knows? Maybe you'll fall in love with them as much as I'm in love with them. Because yeah, we can do that. So let's talk about web components. I'm very curious to know how many of you have been working with web components or are familiar with web components. Like maybe raise your hands. Okay, that's quite cool. That's quite impressive. Nice. Very, very nice. So for those of you who do not know what web components are, they're basically a set of standards, a set of W3C standards. And they will allow developers, they allow developers to create reusable widgets or components for web applications, basically. So web components is basically just an umbrella term for a set of standards. And these standards are custom elements, templates, shadow DOM, and HTML imports. And I'm going to go through all of them, like, just because I think you can't speak about Polymer without really understanding what web components are. And then after that, we're going to speak about Polymer. So let's take custom elements first. Custom elements basically allow you to extend HTML. They teach browsers new syntax that you're creating. And by this, they allow you to define your own DOM elements, basically. What this means is that you can do something like this. You can create this ASCII smile tag, and you can yourself define the behavior of it. And the browser will just learn that, and it will extend its vocabulary with what you've created. It's important to know that custom elements give you a few very basic but very important things. One of them is a declarative way to create components. Also a very readable way to do that. So you're probably all familiar with the infamous div soup. So when you're trying to figure out a document, like the structure of a document, you're most of the times lost in this whole nested divs tree. Custom elements will fix that for you, because everything will become more readable. So if you have elements like the ones that I've showed you, like the ASCII smile, everything will become more readable. So not just for you, but also for other developers that are reading your code. It also adds meaning to your document. So I think for everybody, it's quite clear that if you would run across a tag like ASCII smile, I think it's quite clear what that tag does. So it really adds this meaning to your elements, and I think that's very important. It also allows you to create reusable components, which is like a big plus, because that means that you write it once and then everybody can use it, which is actually really cool. You can reuse it through your applications, but you also open doors for other developers to use your components or even extend your components. All these components are also very they're self-sustainable, which is another important thing. And what it's very important for you to remember from all this is that all these custom elements that we're talking about, in the end, they're just HTML. So how does this work? So when you're creating custom elements, you have to register them. So the browser, basically, each document has its own registry. And in order for your element to be recognized, you need to register your new element into this registry. How do you do that? So the document API has this register element function, and you can basically do that. And by this, you're just passing in the prototype of your element that you're defining, and that's basically it. So what I'm doing here, I'm specifying the type of my element, which is ASCII smile, and that's basically the tag that you're going to see in your document. And then you're defining the prototype of the element, which is basically which native element or which element is your custom element inheriting from. And by default, a custom element will inherit from an HTML or an SVG element. Another thing that you might want to know is that this function returns a constructor function. So you can also imperatively instantiate your custom element. Usually you'll just do this. So in your document, you'll just add this tag, and that's basically it. And you can use your element wherever you want. There is another thing which is called type extension custom elements. And these are basically custom elements that extend existing elements. You can extend either native elements or your own or other people's custom elements. And you do that, it's basically kind of the same syntax, so you're still using the same document API, so the register element. The only difference is here that you can see that before we had the HTML element prototype, whereas here we have the ASCII smile prototype. So basically, we're taking that prototype, we're making our new element a type of that, and we're basically extending it. And then you have the extends keyword there. And this will look something like this. So it's still an ASCII smile tag, but then you have this, this is property, which basically tells the browser that you're taking an existing element and you're just extending it. Oh, and by the way, if you have any questions during the talk, please feel free to ask. I'm very happy to answer. Right, so when you're creating custom elements, there is something that we call lifecycle callbacks. And these callbacks correspond to like very important moments in the creation of your custom element. The first one is the created callback. And this callback is called when, well, callback is called. But this function is called when the instance was created and when its definition was registered. Then you have the attached callback, which is the moment when your custom element is attached to the document. You have the detached callback, so the moment when you detach it from the document. And then, of course, you have the attribute changed callback. So, of course, you're probably going to create custom elements that have attributes on them. So whenever these attributes are changing, you're probably going to want to hook into that. And this callback will allow you to do just that. Right, so that was custom elements. Then we have templates. And templates basically allow you to store HTML inside of another HTML document. And you do this with a custom tag called the template tag. And the content of this template tag is basically parsed, but it's not rendered. So what you're getting is, you're getting a way of declaring DOM inside of your DOM that is not rendered. It's basically an inert piece of DOM. And that's basically because the contents of this template is attached to a document fragment that does not belong to the main document. And that's the reason why this content is inert. Being inert means that if you have images, if you have scripts, if you have whatever may you have, none of that will be loaded. None of that will be executed. It's just going to be there. And until the moment you stamp it out from that place, you clone it, and you attach it to the actual document, that DOM is going to do pretty much nothing. So what you need to remember about this is that it's parsed as HTML. It's not going to be rendered. It's going to be cloned, and you'll need to do that in order to attach it to your document, to the main document. And it's this piece of DOM is going to be instantiated at runtime, just exactly when you need it, which I think is very cool, actually. So how do we do that? Well, I told you there's this template tag. And basically in this template, the content of this template can be pretty much whatever HTML you want to have. You can have styles, you can have scripts, you can have links. None of that will be loaded, none of that will be executed. So you pretty much, it's just HTML, and that's it. And in the moment that you actually want to use this template, the content of this template, what you're going to do is you're going to clone the content of this template, and you're going to stamp out a host node, and you're just going to attach the content of that template to your node. And that's the moment when the content is going to be rendered. And that's it. Do you have any questions so far? Okay. Then I'll go to Shadow DOM. So Shadow DOM is kind of supposed to be one of the complicated of the 4 standards. And it is. I read the specs, and there's quite a lot in it. Shadow DOM basically is a way of, yeah, how can I put it? It's like you have your custom element, and then it creates a small bubble around it. Shadow DOM makes sure that CSS is encapsulated, so there's no bleeding in or out. If you have certain classes or IDs declared in the template inside of your Shadow DOM, those will not leak out. So you can have the same IDs, for instance, with elements from the light DOM. So it gives you that. It hides the inner workings of a custom element, and it hides that away from the outside world. So in that way, it's a very nice separation of concerns. So you as a consumer of the custom element, you don't have to be concerned about how that custom element is implemented or how it looks like. You're just going to use it. And Shadow DOM does that very nicely for you. There are a few important concepts when it comes to Shadow DOM. We have the document tree, which is basically the node tree whose root node is a document. You have the shadow host, which is basically like an element from light, like in the light DOM, that can just host a shadow tree. You have the shadow tree itself, which is the node tree that is hosted by the shadow host. And then you have the shadow root, which is the root of your shadow tree. This can be a bit confusing, so I think this maybe will clear it up for you. So on the left-hand side, the nodes in green, that's pretty much your document tree. So it's like what you see in your DOM. And then on the right-hand side, in pink, you have the shadow tree. You have the shadow root with all the children. So the moment you're attaching a shadow tree to a shadow host, something like this is going to happen. Does this make sense? So you can notice that basically all the children from the light DOM disappear, and they're replaced by the children in the shadow tree. And I actually have something very cool to show you, if internet helps us. Yes, it does. So there's this very cool tool, which is called the Shadow DOM Visualizer. And this tool can really show you how the two trees get merged together. It's a quite complex algorithm if you read the specs, but I think this is a very nice way to visualize it. So I'm not sure. Is this readable for everybody? Right. So like in the blue square, you have the host node. So you can see that you have these H2 tags and this div. And in the kind of yellowish square, you have the shadow DOM. This node is your host. So this is where the shadow tree is going to be, this is the node where the shadow tree is going to be attached to. And you can see that. So you have the host here, which was the div with the ID host. And then you can see, so the header, so all these elements that were part of the shadow tree and that were attached to the host. And then you have something which is called insertion points. And that basically allows for this part to happen. I'm not sure if you can see where I'm pointing, but it's here. So remember I told you that all those light children disappeared? Well, there's actually a way to integrate them in the final DOM tree. And that's by using insertion points. I'm going to speak more about that when I'm talking about Polymer, so I will not insist very much on this. But I hope this makes it more or less clear for you. And then you also know about the tool, so you can like check these things out. It's really very cool, and you can edit, and it just reloads, and it shows you. I mean, it gives you the live result back. Right, and then there's HTML imports. And HTML imports basically allow you to include HTML documents in other HTML documents. It's like in a very simple and declarative way. It's basically something like this. It's just a link with an import a rel attribute and just a URL. I mean, yeah, the URL to the document that you're importing. And that's pretty much it. The caveat with this one is that you have to remember that when you're importing a document, what's returned from that action, it's the document itself. It's not just the content. So if you want to start manipulating the content, you'll have to do something like link.import, and that will give you the contents of the document. Right, so let's have a look at, like, if we put all these things together and if we give a bit of love to the web. If we would write an ASCII heart custom element, what would that look like? And it would look like this. Can everybody see this? Okay, cool. So yeah, I mean, it's pretty much everything that I've discussed so far, just like all put together. So we have the template to which we attach some styles, and we have this div with the small ASCII heart. And then we have a script that basically creates a shadow tree, and it takes a template, it clones it, it attaches it to the shadow root, and then it just registers this element. It's pretty much it. I think it's quite straightforward. Are there any questions about this? Okay. Let's see. Let's go back. Right. And the result would look something like this. Cool. So let's talk a little bit about Polymer then. How many people are using Polymer here? Nobody? No, there's one person. Cool. Right. So Polymer is basically, it's a library that is built on top of the web component standards. And it adds some syntactic sugar and some extra features that are not there in the web component standards yet. I'm not even sure if they will ever be. And it also fixes another issue, which is basically browser compatibility. I didn't speak about that with web components. Not all browsers are there yet. And also regarding the standards themselves, it's only templates that have actually made it a standard per se. All the other three are still working drafts. And Polymer kind of fixes that for you. There is a polyfill, which is called Web Components.js, and Polymer uses that. So if you want to write pure vanilla web components, you can do that, and you can just use that polyfill. But there is a lot more that Polymer adds to that, and I think it's really cool what they're doing, and it's very interesting to have a look. That was just as a side note. So yeah, if we have a look at the web components stack, so you see we have the web components primitives. So that's basically like the pure vanilla web components. Then on top of that, you have the Polymer library, which adds, as I told you, like all the syntactic sugar, and it also it adds some sugaring regarding how you declare things and so on. And then on top of that, there's also a custom elements library. The custom elements library, it's part of the Polymer project as well. I actually want to take a quick moment to have a look at that. So there is this thing called a Polymer catalog, and they have like these categories of elements. I'm not personally super familiar with all of them. I have looked at a few of them. I was mostly interested in mostly the implementation. It's really cool. They have a saying. So there is a saying. There are a few talks about Polymer and web components, and all the speakers were saying, yeah, there's a web component. There's a Polymer element for that. And it's kind of true. Like if you look at this library, there is so much work in there, and there's so many elements. It really feels like that there is an element for everything. So my advice, if you start working with Polymer, really do have a look at these elements. They're super nicely written, and they're very, very helpful. Right. So that was the last layer in the web component stack, the custom elements that I mentioned. So what are the features that Polymer adds? Well, there's element registration. We had that in web components as well, but it adds some syntactic sugaring. It makes everything much easier and much nicer to declare, in my opinion. It introduces this notion of local DOM. It also introduces declared properties and how to handle them and how to manage them in a better and nicer way. It introduces the concept of data binding. I mean, well, okay, not the concept per se, but web components, for instance, doesn't have that. Doesn't have this concept of data binding. You cannot do data binding with web components, but Polymer allows you to do that. It also has a very nice solution for styling. And there are a few more other things, but those are a bit more complicated, and I didn't really want to go into them at this point. So I'm going to take each one of these, and we're going to go through them and see like what exactly do they add. So with custom element registration, what Polymer does is it basically provides us with a Polymer function. And this function just takes the prototype of the new element, and it just gives you back a constructor function, just like with web components. And that function allows you to imperatively instantiate your elements. This looks something like this. The is property on the prototype is a mandatory property. That's basically the type of your custom element. That's also the tag that you're going to use in the DOM when you're going to use your element. And then you have some other properties on the prototype, like the properties property, the ready functions, like all the callback functions. But I'm going to get into that very soon. And that's pretty much it. And then there are a few ways in which you can instantiate your components. So as I told you, it returns a construction function. So you could instantiate like by calling the new constructor. You could also use the documents API create element. That would also work, or you can just do it declaratively like this. Either one of this, it's perfectly valid. It really depends what you want to do with it. So remember I told you with web components that by default they inherit from the HTML element. In Polymer, when you're calling the Polymer function, this will set up the prototype chain for you. And it will chain it to a Polymer base, which adds a few features to the prototype. This basically looks like this. So you can see that you have all the callback functions, but it also adds a few extra things. I've just put like a small part of it, but you can also. But I wanted to include it in the talk because I wanted to show you that like also by default, like at the end of the day, it still inherits from the HTML element. That was just my thing. I really wanted to know that. Right. There's also something that is called class style constructor. And that basically allows you to create a custom element, but not register it immediately. So what that means is you're going to use the polymer.class call. And this function pretty much gets the same parameter, like prototype parameter, as the Polymer function does. The only difference is that with Polymer, you create the element, but you also register it immediately after, like the function does that for you. Whereas with a class style constructor, you will have to do that manually. So you will either have to use the .register element. You will have to use the .register element. And then for the instantiating the instantiation of your element, you will just pretty much use the same thing. It's pretty standard. It's the same thing. Polymer also supports type extension elements. Remember, I told you that your custom element can extend other native elements or other custom elements. With Polymer, you can do that as well. And it's, well, I think that the syntax is very similar to vanilla web components. Right, and then for the instantiation, it's pretty much the same thing. The only difference with Polymer is that you can only extend native elements. If you want to extend other custom elements, you'll have to do that using a thing that's called behaviors. It's outside of the scope of this talk, but just keep that in the back of your head if you run into it. The Polymer documentation is really, really good. So if you stumble upon it, then that's definitely the place where you should go and read about it. But do know that there is this difference. Polymer also adds a bit of syntactic sugaring on the lifecycle callbacks. So it has the created, attached, detached, attribute changed callbacks. It adds an extra callback, which is the ready callback. And I want to speak a little bit about what each one of them does. So the created function is basically the equivalent of the created callback in like vanilla web components. This function is called when the element was created, but its local DOM has not yet been initialized, and also the property values were not set. This is what ready is for. So ready is called when both the DOM is initialized and these property values are set. Then for the rest of them, the attached and detached and attribute changed, they're pretty much the same thing. It's just like a sugar layering on top of them. But like they are called still in the same moment in the life cycle of the custom element. I told you that Polymer introduces this notion of local DOM. Local DOM is basically the DOM that your custom element will create. So in web components, we had shadow DOM, and you're probably going to think it's more or less the same thing. It depends. That's the answer. Because Polymer has multiple implementations of local DOM, so it can use shadow DOM with browsers that support that, but it also has its version or version implementation of shadow DOM, which is called shady DOM. This is used for browsers that do not support shadow DOM, but in the current version, this is the default implementation that Polymer uses. And if you really want to use shadow DOM, there is a flag that you can set, and that tells Polymer that, okay, for browsers that support this, I really want to work with shadow DOM. And for the other browsers, it's gonna default to shady DOM. Does this make sense? Okay, I hope that's a yes. Right, so how do we create local DOM? Polymer provides this DOM module tag, and that pretty much creates it for you. So there are a few things with the DOM module. First of all, that's the place where your template is going to go. That's also the place where you can declare your element. That's the place where your styles will go. So it's like a wrapper around the whole creation process of your custom element. It is not mandatory, for instance, for the script tag to be in there. So it could live very well outside of that tag. It really depends of your preference. But it is important that the template is parsed before the custom element is created. And I think that makes sense. But that's pretty much it. And so basically, in this case, your local DOM would be that div with the heart ID. And that's it. Let me go back to this slide. So there is a question of the moment you create local DOM, how can you access the nodes inside that DOM? And Polymer has this concept of node finding. So what Polymer does is it basically keeps a map of all the static instances in the local DOM. And from all of these instances, all the nodes that have IDs are stored in this.dollar property, and they're stored by ID. And okay, sorry. Right, I wanted to tell you how you're going to access that, but I'm going to show you in the next slide. So that's basically, it's for the static nodes. It's really important to remember that, because you can also have dynamic nodes that are created at runtime, and these nodes can be selected using the $$ sign, and then you can pass in a selector there. So returning to our this.dollar, how that's going to work is, so you see here, hopefully. So you see here that in the ready callback, because we have the ID on our div, it's very easy to access that, and then, for instance, do some manipulation. Like in this instance, I'm just setting up text content to this node, but then, of course, you could do whatever you want with it. Does that make sense? Okay. Right. So this is, I think, pretty much straightforward. But there is another thing that we should consider. So actually, I'm not even sure if we mentioned the ASCII shrug. Did we mention the ASCII shrug? I don't know. Anyway, but let's say, for instance, that you don't like the face of the ASCII shrug, and you want to make it customizable. Of course, that will break his heart, and he will be very sad. But he's a smiley, and he'll forgive you because, yeah, he knows that, well, yeah, that's all you can do. And this is where insertion points come into play. You remember that I told you that I'll speak a little bit more about them when I get to the Polymer section. So how Polymer deals with this, it's via a custom content tag. So this is how you can declare all your insertion points. This element also supports a select attribute, and this will help you filter through the content that you want to leak into your component. So what does that mean? Okay. So let's say you have an ASCII shrug custom element, and part of its children are these two spans. One has a my face class, and the other one has a my other face class. The implementation of the ASCII shrug, like if you look at the template, it has a right arm, and it has a face, and it has a left arm. And you can see that for the face, we're actually not really declaring anything, so we're leaving that open to the user of the to the consumer of the custom element. So what we can do here with the insertion points is we can do something like this. So we can pass in the select attribute, and we can select the class of the node that we want to insert in our custom elements template. And that's it. Unfortunately, my result doesn't really show that. But basically, what this will do is it will stamp out that span, and it will just transclude it in the place where we have the content defined. And that's it. And those are insertion points. It's very important to remember that when you're working with local DOM in Polymer, there's a DOM API. Polymer provides this for you. It's pretty much, it has the same signatures as all the standard DOM. There are a few exceptions, but we're not going to go into that. I'm just going to give you a few examples. Like this is how you would actually access this API. And like here, you can find a link of like where you can find all the specifications. Declared properties. You can think of declared properties as a public API of your element. That means that you would probably want to define an element that has some attributes that you can pass some values into. So you want to pass some data into your element. This would look something like this. So if you have an ASCII hello, you would want to pass in a face and a waving hand. So you want to specify with which hand is going to wave it back at you. When you register this element, it's basically what we discussed until now. But to that, you're going to add this properties property. Remember, I think I showed it at the beginning when I described the Polymer function. So this is where it comes into play. And what you're going to do is you're going to declare these properties. So you see that we have the face and the waving hand properties that match the attributes in your element. And what's important to remember is that these properties can have properties themselves. So they have a few, like the type and value. I'm actually going to just put them all here. So these are a few. There are a couple more, but I didn't go into them. I think these are some of the most important. So you have the type and the value, the read-only, the notify, and the observers. So all these properties of the properties will define how they will be managed, but also how your custom element will behave. I mentioned data binding. It took me a while to get this. Like, it looks straightforward at the beginning, but it's actually, there's like a small trick. And actually the small trick in that is like to really remember to understand what data binding in the context of Polymer is. So data binding, it will bind a property or subproperty of your host element to a property or an attribute of one of its child elements. And it's really important to remember that. So what does this look like? So we have an ASCII host custom element declared here. But you can see in the template of this element that you have an ASCII smiley. That's also another custom element. And you can see that we're binding the color of the ASCII smiley to the disco color that is defined on the ASCII host. So that's what I meant by that we're binding a property or a subproperty on the host element to a property or an attribute to the child element. So if you have this point where you declare that the color is bound to this disco color property, that means that that property has to exist on the host of that element. There are two types of binding annotations. There are the square brackets and then the curly brackets. Square brackets will mean one-way binding. So that means that the data flow is downward from host to child. But the curly brackets will mean that it can be both ways. Like it could be either one way or two way, and that depends on how the target is configured. And that I found very confusing in the beginning. So let's explain that a little bit. So first of all, we have one-way data binding that goes downward. So you can see here, because we have the square brackets, that means one-way binding, and that's it. It's no matter how your child element is configured, the parent, so the host element will not allow it. So it will just not two-way data bind. But we have also one-way binding downward that has like a different configuration. So in this configuration, you can see that the host element will allow it. But for instance, you can see that the child element for the color property, that's configured with notify false. And that means that if there are changes that happen to this property in the child element, the parent element will not be notified of that. So it's still one-way data binding, even though the syntax would look like if it were two-way data binding. There's also one-way data binding upward, so that means from the child to the host. And that's because the child property can be defined with this attribute read only to be truthy, and that means that this property is not allowed to be set by either the host element or by data binding. So that means that even if the change happens in the host, the child will not, that change will not propagate to the child. However, if this property changes in the child, that will propagate upwards to the host. And then there's, of course, two-way data binding, which looks pretty much like this. You can also bind to the text context, and that's pretty much straightforward. You basically have these properties defined on your custom element, and then you can just use them in the template. So you can just bind those properties in your template. And last but not least, styling, which is very important. So there are two ways to go around this. You can do scope styling using the style tags, and these are placed inside of the template tag, and that will look something like this. You see here that you have the host selector that basically selects your host element. And then if you want to select if you want to declare specific classes for your local DOM, you can just do that with like how you would regularly do it in any other kind of HTML or CSS. But there's another way around it, and that's the moment when you start wanting to separate your styling from your HTML. And those are called style modules in Polymer. And these are used to share style declarations between elements. And they would kind of look something like this. So what you're basically doing is you're creating this DOM module like you would do with just any other custom element. You're declaring the style, or you can declare all the styles that you want to share there. And then what you would do is you would import these styles into your element. And then you can just use them to style your host. There is, sorry, I'm not sure if this is readable. There is this custom style property on the style tag and the include attribute. And this will tell Polymer that it's actually dealing with kind of an external style sheet. There's no such concept of external style sheet anymore. That's been deprecated. But I'm just referring it to that because for me personally, it helped me understand. Right, so I wanted to live code for you, but apparently I only have 1 minute left. So that's not gonna work. But I wanted to tell you a last story, which is a funny story. So yesterday, I was with a couple of friends and we went to the speakers dinner, and it was like very, very nice. And on our way back, we ran into this very cool, we were going through the underground train station, and we found this like very cool drawing that like took me by surprise. And I really had to tweet because like this whole talk was about, was really around Smileys and ASCII Smileys and Poly Smileys. And then it was really funny for me to come here and then just one day before the talk to run into this thing. So it was, yeah, it was like the irony of it all. And it was really cute, and I really had to smile on the inside, and I had to take a picture of it. That's it. Thank you. And so because it was a very long talk, it was actually one of my longest talks that I gave until now, and I was afraid that maybe people will fall asleep. So I brought stroopwafels for you. I'm not Dutch, but I live in Amsterdam, and it was the last thing I did when I left from the train station. I bought stroopwafels, and people were looking like me because I came with big bags of them. They're for you, and they're very yummy. They're quite addictive. So please come and take some. And I also have some polymer stickers if you want. So just come over. And also if you have questions, I'll be more than happy to answer. I'm sorry I went over time and I didn't give you the time to do that.